In this video, we're going to talk about how we design object-oriented programs, more specifically how we design classes, what methods and properties really are for, and what the difference is between an instance method and a static method. So what are classes in C#? Right? I've made some hand-waving noises about how classes are like mammals or newspapers or something like that. Well, in C#, classes are types. In fact, most of the types that we work with, most of the reference types that we work with, are classes. Classes contain members. Members are things like fields, properties, constructors, methods, indexers, events. We're going to talk about all of those in detail in this course. And we're going to design a program that uses a bunch of classes. And I'm going to pick this program, and we're just going to design it from start to finish over the next several episodes. There will be a few where we digress to have some different classes that illustrate some different concepts. But by the time we're done here, we're going to play Hangman. And if you haven't played Hangman before, if you've not encountered that game in your childhood, it's a game to teach children how to spell. One person picks a word. In this case, the computer will pick a word. Then the player guesses what letters are in the word. But you're only allowed a certain number of mistakes. And if you make too many mistakes, then you're dead. So I said last time that when you're designing a new program, you should think about the business domain of that program. So what are the things in this domain? There's a bunch of different business concepts that we could be concerned about. First of all, there's the game itself. And it seems clear that the thing that we are primarily talking about here is a game. So it seems sensible that it should be an object in the domain. We have players. In this case, we have one player, and then the computer will take on the role of the other player. We have the word that was chosen. That seems like it's going to be important. We have the list of words that the word was chosen from. Somehow, the computer is going to have some sort of lexicon somewhere that keeps track of all the possible words that it could choose. And we've got to keep track of things like the outcome. Right? The game could be won, or it could be lost, or it could be still in progress, neither won nor lost. And let's think a bit about the sort of workflow, right, of this program. The game is going to choose a word, probably going to choose a word at random. We've got to have some kind of user interface that displays to the user what's going on and asks them to choose a letter, and then figures out whether that letter is in the word or not. So the player will make a sequence of guesses, and the game will figure out what happens on the basis of those guesses. Either the player will win or they will lose. All right, so with all of that in mind, let's just, without speccing this out further, and clearly what we're doing here is we're starting to write a specification. Let's just build some classes. We're not going to put any game logic in them. We're just going to try to get a sense of how the parts fit together. So here in Visual Studio, I have made a new project that I'm cleverly calling Video 11. It's yet another console project. It's no different than any other console project that we've seen so far, except that you'll notice there are 4 classes in here. There are 4 C# files: Hangman, Outcome, Player, and our old friend Program.cs that we've seen every single time. And rather than starting in Program.cs, as I usually do, I've started in Player. So I've created the class. As you might expect, having seen enums and having seen many times us declare the class program, the way you declare a new class is you just say class, and then you have the name of the class. So we have a new class called Player. Then the body of the class is inside curly braces. And this class right now, I'm just going to give it one member. It's going to be a property called name. The name is going to be of type string. And it's going to be a read-write property. So the way I express that is I say the property has both a getter and a setter. Now, I'm just going to let this pass without further comment at this time. We're going to have another video coming up where I talk about what properties are in more detail and how to write read-only properties and all of that kind of thing. Right? But just for now, let's say that we have a kind of thing, a class called Player. What do players have? Players have a name. Right? So we can already start to see the relationships that we've got here. A player has a name. We have composed the player out of a name. Right? We have taken a bunch of stuff. In this case, the bunch of stuff is only one thing, a string, and we've made a player out of it. All right. So now let's look at a considerably more complicated class. I've made a class here called Hangman. OK, so this will be the class that represents the actual logic of our game. And so what things does a game have? Well, a game has a player. So let's make a property on this class called player. And immediately we notice something interesting. Right? This property is, first of all, public. And I'll say what public means later on. Then we have a type here, which is player. Then we have a name of the property, which is also player. And then we say get and set, meaning this property can be both read and written. The thing that I want to emphasize is that the property of type player is called player. And this is very, very common. C# was carefully designed so that the compiler did not get confused when this happened. This was originally called the color problem, because the first time the C# designers ran into it was they had a type, an enumerated type, in fact, called color. And then they wished to have an object that had a color. And naturally, the property would be called color, and it would be of type color. So you had to say at some point, color of type color. So this became known as the color problem. So this is perfectly legal. Do not ever worry about creating a property whose name is the same as its type. It's done all the time. All right, so enough about the color problem. Our Hangman class has a player. It also has a word list. Now, what's a word list? Well, it seems reasonable that a list of strings is a word list. So we have another property here. This is, we will see later, a bit of a poor design choice, but explaining why will take us some time. So we'll get to that later. We've got the word that the player is trying to guess. That seems like a likely property to have. And so we have that it's a string, pretty clearly. We wanted to say that a game has a particular outcome. It's either won or lost or in progress. So it seems reasonable that that should be an enumerated type. So I've made over here another file that just contains this tiny little enumerated type. And this is pretty common when you're building up a project, is to have one type per file, one file per type. It's not necessary. You could write this entire thing in one file if you wanted. Or we'll see much later on in this series, there's a way to take a bunch of types and break them up amongst many files. But we're not going to do either of those two things here. We're just going to say we're going to have one type in one file. So we've got this tiny little enum outcome. We're going to use it here. And again, we've got the color situation, a property called outcome of type outcome. And then we're going to have one method. Again, I'll come back to what public means in a little bit. The method is going to be void returning. It's going to be called guess. It will take a character, which is the letter being guessed. And we will put the logic for the player's guess here. This is where the actual magic will happen. This will be where the game is implemented. All right, so let's then take a look at our main program. And once again, we've got our old friend, the program class. We make a static main method. And what's this guy going to do? Well, we're going to make a new player. We're going to initialize the name of the player to Eric. We're going to make a new Hangman game. We're going to say that this player is the player of this game. And we're going to guess the letter A. Right? So again, we haven't put any of the logic in here yet. The whole point of this thing is to just kind of sketch it out, see if it compiles, see if we've got the relationships between these things correct. All right, so let's debug into this. All right, so I create a new player. And if I take a look at this in the locals window, I can see player has a name. The name is currently null. Right? So this is a property. And then when I set the property, this updates down here. So the player has a name. The name is now Eric. I'm going to create a new Hangman game. So this guy gets initialized. It has an outcome, which is in progress, a player, which is null, a word, which is null, a word list, which is null. When I set the player, the game's player becomes the player that was just created. You'll note that I can drill down into here. Right? And now I can see that the game's player has this name. And so you see how this composition works. Right? I am building a simple object, like player. And then I am using that to build a more complex object. I'm building the Hangman object out of that. And that is how all of this works, right? Is we just build more and more complexity by putting more and more simple parts together. All right, and then I'm going to call game.guess. So I'm going to step in here. Now this is, I think, the first time that we have debugged into an instance method instead of a static method. And the main difference between an instance method and a static method is when we called this instance method here, the receiver was a specific instance. That's why they're called instance methods, right? This method was being invoked on this game. And so you would think the method might like to know upon which instance of the Hangman class was this method invoked. And the way that happens is there is an invisible parameter. You'll notice it's nowhere in this list here because it's invisible. That is called this. And if we look in the locals window here, you can see that there's a this, and there's the letter that was passed in, the letter A. And if we pop this open, we see that, oh, sure, we have the outcome that's in progress. We have the player named Eric. We have the word, which is still null, and the word list, which is still null. Right. Now, this is not a variable. Letter is a variable. I could change letter if I wanted to. It's not a good idea to. I don't like to change the values of parameters that are passed in because it makes it harder to debug. But this isn't even a variable. This is just a value. You can't change it in a class. Now, you notice that the unset properties are null here. Right? We set the player and the name property, but the word and the word list are still null. We did not have to initially assign those. You remember with local variables, we always have to say what the value of a local variable is before we use it. But with these guys, we could write out this.word right now, and it would be just fine. The compiler would allow that, and it would write out null. And the reason for that is it's actually quite difficult to do the analysis that is necessary to figure out when a property has or has not been written. And so C# doesn't attempt to do so. It just says, if you haven't written it, then I will for free give you a default value. And that is also why the default value for outcome is in progress. Let's take a look at that real quick here. If we go here, if we mouse over that, you can see when we mouse over in progress, it says this is 0. This is the first element in the enum. It's automatically assigned the value 0. And since, as I've said many times, enums are fancy integers, the default value for an integer is 0. So the default value for an enum is also 0. Summing up, when you're doing an object-oriented design, think about the things that are in your business domain. Think about their relationships. Create some classes, create some public methods and some properties that represent those concepts. And the initial design that we've come up with here is very unpolished. This is going to be close to our final design, but we are going to tweak a lot as we go through the next many episodes of this course to try to get this closer to something that's a really solid, really good design.